Okie dokie, it's lesson 20. We are almost at midterm in SUNY Geneseo's Calc 1. Hope you have enjoyed the ride. On today's show, we take a look at the derivatives of logarithmic functions. Specifically, we take a look at the derivative of the natural log function. We take a look at what happens if y is the natural log of x. How do we find its derivative? You're familiar with this function. It looks something like this. And so we're imagining all of the little slopes we could draw all the way along the graph. All of those slopes are positive, so whatever derivative we take has got to be positive for all values of x greater than 0. And we're also going to take advantage of the fact that we know that if y is the natural log of x, that e to the y is equal to x. That is what we mean when we talk about the natural log. You'll remember that the natural log is a log base e, and then when we convert a logarithmic statement to an exponential statement, its base to the exponent is the log, just like that. Well, lucky for us, we know how to take the derivative of that red line. We take the derivative of this using implicit differentiation. The derivative of e to the y is e to the y times the derivative of y with respect to x. Derivative of x is 1. So dy dx is 1 over e to the y. We don't have to leave e to the y there because we know what e to the y is. So dy dx is just 1 over x. The derivative of the natural log function is 1 over x. At 1, 0, the slope is 1. At 2, the slope is a half. As we go, the slopes get smaller and closer to 0, which makes sense with what we know about that graph. So this is the first key thing for us to know. The derivative of the natural log function is 1 over x, which means that we can find f prime of x if f of x is the natural log of the inverse sine of x. Sure we can. Sure we can. So we're looking for f prime. It's a natural log function with a thing inside. This is a function of x. So the derivative of the natural log of something is 1 over that something times the derivative of the inside, which you remember from a previous class. Sorry, that's a period, not a decimal point. Maybe I just get rid of that. Likewise, we could find g prime of x if g of x is the natural log of x squared plus 3, and that shouldn't be too terribly difficult. The derivative of the natural log of something is 1 over that something times the derivative of that something, and we've got it. We could choose to make things a little more complicated. Find h prime of x if h of x is the natural log of x cubed cosine x over x squared plus 4. Well, then that's going to be a pain, isn't it? Like, that's just a pain. Right? That's, wow, gosh. So what would we do? We'd do 1 over this times the derivative of this. Well, golly, nobody wants to do that. But we remember that this is a natural log, so all the properties of natural logs from high school come into play. This is a quotient, and since that's a quotient, notice I'm not taking a derivative here. This is not h prime, this is h. This function is the same as this one, because you remember from your high school work that when we have a quotient, we can subtract those logs. It's something we went over even in week 1. And this thing right here, that's a product. So still not taking derivatives, right? We can do that. We can use properties of logarithms in a derivative. It is allowed. So now I can take derivatives pretty easily. H prime of x, well, the derivative of this is 1 over the thing times the derivative of the thing, 1 over the thing times the derivative of the thing, 1 over the thing times the derivative of the thing. Okay? It is worth you trying. Find f prime if f of x is the natural log of x squared plus 3 to the 5th. It's worth giving that a go. You may want to do that. It's worth pausing the video to do that. There is one other thing we should consider before we show up in class together. What happens if you're taking the derivative of a log and the base is different? Like the base isn't e. What do you do if the base isn't e? Well, that's not too terribly tough because we know from high school that this is the same as natural log x over natural log b. We know from high school that the change of base rule applies. I can take any other base, like the natural log, and make it log of this over log of that in that base. So in this case, we remember that natural log b, that's a number. So this is just some number times natural log x. Well, how do we take the derivative of that? Well, the derivative of that is the derivative of this, but that number just comes along for the ride, and that's usually written as 1 over x times ln of b. So this is the derivative generally. If it's the natural log, then that's e, and the natural log of e is 1, so we're still fine. What do we do if we're taking the derivative of an exponential function, but the base isn't e? Well, how does that go? Well, we know how this works. If this is true, then this means that the natural log of y is x times the natural log of b. We take the derivatives on both sides. We take the derivative on both sides. You might want to think about why this derivative is that thing right there. Think about your favorite numbers, 6, 12, whatever it is. This is just that number times x. You might want to think about why that's true. So this means that dy dx is y times the natural log of b. So if the base is not e 2.718281828459045 approximately, if the base is not b, if the base is not e, if it's some other base, we can take the derivative of the log function, we can take the derivative of the exponential function. Some things you might want to know how to do. Let's consider at least one of them. There. We'll consider at least one of them just for practice's sake. So it's a product rule. The product rule is so much fun. It's one times the derivative of the other times the derivative of the one. So let's see. Let's do derivative of 3 to the x times the other thing and add 3 to the x times the derivative of this thing, which according to the other slide is that. Do we simplify? Heavens no, we don't even try, not a little bit. Very good. You should probably try. Oh, yeah, yeah, yeah. Yes, you should try that. When we gather, we're going to practice a little bit and we're going to learn something new. So be ready when you show up. Looking forward to it.